Right. I think it's important every now and again to take a step back and to look at the bigger picture and not get lost in the technology, but get back to the fundamental reasons why we use this technology. And one of the key points as far as why we use this technology relates to contrasting two different words. And these words in everyday usage might be synonyms: data and information. You know, do you have the data about, you know, what are the monthly average temperatures in Los Angeles? Do you have the information about that? But really, people in information technology use these two words differently. Data are raw facts. Information is data organized in a manner that can be used for something. An example I like to give, and I've given this before, so maybe you've heard it before in other classes, or maybe not, is if you say that, let's say the branch of an organization had $300,000 worth of sales last month, the month of September. No, last month is October. Yeah, the month of October. Is that a good thing? You can't make that judgment, right? That's a piece of data, but you can achieve, you get no value from that. You can't use that for anything unless you know some other stuff, unless you can put that data in context, compare it to other data, organize it with other data. One way that you could tell, one way you could look at it is compare that $300,000 worth of sales compared to what was budgeted. If they budgeted $200,000 worth of sales and they had $300,000 worth of sales, they did a great job. If they budgeted $400,000 sales and they only got $300,000 sales, and they haven't done that great of a job. Maybe compare them with other branches. You know, what does $300,000 mean? Is it near the top of the list for branches, or is it near the bottom of the branches? Compare it with expenses. Okay, yes, they sold $300,000 worth of stuff, but what were their expenses for the same period of time? All these things that I'm talking about when we talk about combining data or organizing the data transforms that raw piece of data into something you can do something about. You know, if $300,000 was record for the best branch sales in the company's history, maybe you give the manager a bonus. If it's way under budget, maybe you have a talk with the manager. Something that you can do something with. And one thing I want to emphasize, especially with your project, is have at least a few queries in your application that provide information beyond just like a simple listing. Like we all know pretty easily now how to create entities, or we should know how to create entities. Hopefully we're getting down creating relationships between entities and scaffolding so that you can enter a new whatever restaurant category and get a list of restaurants, get a list of or a list of meals, get a list of categories and all that. That in a way is raw data. The list of the meals is raw data in a way. Now, what one of your assignments are, and I forget if it's the one due this week or next week, is to transform it and to create a menu from it. Well, that's something that's usable. If you simply gave, you know, your customers just a list of all the dishes, you know, that your restaurant served, organized alphabetically or not even organized by the order in which you entered them in, that's not necessarily going to be terribly useful. But if you had it broken down by categories, like, fish dishes, pasta dishes, chicken dishes, beef dishes, or appetizers, breakfast, lunch, dinner, those are all ways that you could take that raw data and make it more usable. So if you're really looking to do an excellent job in your project, which I'm hoping you all are, go beyond the just scaffolding of data and have at least some queries that combine data in ways that would be useful. All right, because that's what really is getting to be a true system that can produce some information that's usable for people to use. In the old days, in fact, this field was known as data processing. And at some point, they kind of changed that to be information technology. That sort of puts the emphasis on the output of a system rather than the raw data that goes in. We kind of have something like this. Data gets transformed into information, which can get transformed to knowledge. All right. Obviously, the data has to be correct. All right. Garbage in, garbage out is one of the oldest adages in information processing. But by the same token, that raw data, if it's just spit back out, entered and spit back out without any transformation or organization, then it's not going to be useful in creating knowledge. What do I mean by organizing it? Well, you can sort data. All right. You can filter data. If I was a credit manager for an organization, would it be worthwhile to see a list of all my customers' accounts? Oh, I don't know. What about a list of customers that are overdue with their payment? Yeah, that's a lot more meaningful. Maybe organized or sorted by state or region. So I could call the appropriate regional manager and try to figure out why the balances haven't been collected. Combining data with other data. Example I gave with the branch that sold $300,000 worth of merchandise. Compare that to their expenses. Compare that to what they did last year. Compare that to what other branches did. Compare that with budgets. All those ways are taking and combining data to take that raw data and to produce some knowledge. Keep this in mind as you're creating your project and try to have at least a couple instances of where you're going beyond simply just having a raw list of data. And I tried to illustrate that in an example we're going to go over today, an addition I made to the Contoso database. It's not earth-shattering, but again, it produces maybe something that would be useful to someone within the college. The key in doing this, by the way, all the way, to do the filtering and the sorting and all that is queries. And in queries, language is Linq. Language integrated queries, I think that means. And I could probably go on for another 20 minutes talking about what that means. The good news about this is it makes it able to write queries with a greater degree of certainty that your queries aren't going to bomb out and get an error because you called something the wrong thing. You're less likely to do that using Linq because it's built into the language and it can be compiled. I guess now's as good a time as any is to talk about two kinds of errors: compile and runtime. Compile errors are when you go to compile your program and it tells you got an error on line 12. You missed a period in a statement, missed a semicolon. forgot the ending parenthesis. That's a compile error. That's something the machine can check for and give you an indication that there's something wrong. A runtime error is where your program compiles fine and it runs, but under certain circumstances it explodes and has an abnormal termination. It's better to get compile errors than runtime errors, because compile errors, you know that it's a problem. Runtime errors, you don't know that they're problems until people report them. And if you've had a problem with a website, are you necessarily going to contact them and tell them? No, you'll just probably go to a competitor. So therefore, it's better to get compile errors because you can find them, identify them, and fix them, as opposed to runtime errors, which are sporadic and which you might not even find out about until a lot of damage has been done. Well, Linq supports the idea of giving you problems in your queries and with compilers rather than runtime. Okay. There we go. So what I did is I took and created class roster. So we can pick a course and see a roster. And that roster shows us the course name, the department that it's in, the name of the instructor or instructors, because our database allows for multiple instructors per class, and then a list of students. That's something that someone could use. I have things very similar to this in Canvas right now, where it gives me a list of all the students in the class with their email address and other information. And then I have one that shows me the grades for the student, that goes a step further and actually shows grades that those students have. But in this case, we're combining actually a number of entities together. All right. We're starting off with a course. All right. We're pulling from the course the department. We're pulling from the course so I don't mess anything up. Corey actually combines several things together. We can see them here. It combines course information with department information, with instructor information, and student information, and enrollments information and students information. So let's break this down and analyze what we're getting. I think the first thing when you look at a query like this is to identify, are we getting one of a particular item or are we getting a list of items? And in this case, we're getting a single course because it says down here, give me the first or default of these things. I actually do have a redundancy. We can get rid of line 33. That's redundant to line 38, by the way. So, courses. We're going to go and we're going to get a list of courses that match the ID that got passed to it. Let's make sure we understand how that happens. When we go to look at courses, when we look at roster, I don't know if you can see the URL or not. Let's view the source of this page. The link to the roster has an optional query string item of an ID, and in this case, it's 1045. The ID is the key to the course entity. It's the course ID. We use that to retrieve one specific course. So if you're retrieving one of something, you better be passing an ID number, because you want to make sure you get one and only one course or category or meal or whatever. Take a look at the scaffolded code and you'll see IDs being passed around to like the edit and the details and the delete pages. So that gets created when we create these links. Edit ID equals 1845. ID equals, or is that 1045? 1045, 1045, down the line. So all these have the ID on the link. That gets passed on the query string as ID. Remember, things that are passed on the query string, when we call a page that way, we're using onGet method. And that's why when we look at this, we notice that this has an optional ID argument. That's because it may have something on the query string for ID. It better have something on the query string for ID. What if it doesn't? If it doesn't, we're asking for a roster, but we're not saying what class. And that's going to respond with a, this page can't be found. Can't have a roster if you don't say what class you want. So that's what we see right here. If there was no ID passed, then the page is not found. Likewise, if the course is null, after we've done all this querying, by the same token, page is not found. Now, look at the query. Course equals. Look through the list of courses. Include department. Now, we've talked about this before, but I think it bears repeating. What does it mean when we say include department? Well, in the model for course, there is a field for department. How many is it? Remember, the question when I ask how many is it one or is it a list? Well, there's only one department. When we say include department, we're saying when we retrieve the course, populate this department object. Okay, populate that department object. If we didn't do that, then we wouldn't pull the department data. And again, so you kind of have to explicitly say if you want related data. And you might think, why doesn't it do it for me automatically? Well, in a large system, entities are going to be related to a lot of other entities. And you don't always want to pull all the relationships that exist throughout the whole system just to get a simple listing. You know, if I want a list of employees, I might not want a list of the employees plus their hourly, hourly time cards plus their sick day, the sick days that they've taken this past year, plus this and that and this and that. You might not want all that data. So you may only be interested in a portion of the data in this model. But we're not interested in only a portion of the data. We want this department to be filled. We also want enrollments to be filled and instructors to be filled. So therefore, we have includes for all of those. So we're going to fill in that course model, and we're going to fill in the department entry in the course model. We're also going to populate the instructor list and the enrollment list. Remember, there's a many-to-many between courses and instructor, where a course can have many instructors, instructors can teach many courses. Likewise, there's a many-to-many between course and enrollments, because these enrollments show why I'm getting that error. The enrollments show match up the courses and the students. That are associated with this enrollment record. So for every student, there'll be one of these rows in this entity for every course they take. So if we have 10 students, each taking 4 courses, there's going to be 40 rows in this database table, because it matches up. Each one will have their unique enrollment ID, and it will match up. Course student 1 is taking course 1, 5, and 7, and 9. Student 2 is taking course number 12, 15, 16, and 18, and so on down the line. So the course has a list of these, as it has a list of these. So we're saying in this statement, by the way, we want to fill in that instructor list and enrollment list. Then we have a then include. All right. Notice that that's not include. This is a then include. What does that mean? That means that students are not directly related to course. In other words, there's not a course, there's not a student list associated with a course. There's an enrollment list associated with course, and the student is associated with the enrollment. So when you see then include, it means that this entity is associated with this entity, not the main entity up here. So when this is done, we have our course. Oh, and this just says get the one that matches the ID. So when this is done, we're going to have one course object called course. It's going to have all this stuff populated. It's going to have all this stuff populated, including the department object is going to be filled in. The enrollment list will be filled in, and the instructor list will be filled in. And as far as the enrollment goes, student is going to be filled in. We don't actually need the course filled in the enrollments, because we've already retrieved the course data. That would be redundant and just take longer processing time. Again, you only include something in that list of entities that you want if you're actually going to use the data. If you're not going to use the data, there's no sense including it. That just means extra work for the server pulling up this data. So when we're done, we have a course with this stuff filled in, this stuff filled in, this stuff filled in, this stuff filled in. And for each enrollment in the list, we have the student data filled in. So now let's look at the roster CSS_HTML. We're displaying from the model, from the model's course variable, we note is defined up here. This is the guy that gets filled in over here. From that course, we're pulling out the title. We're pulling the title from the course and putting it there. We're pulling the department. Now, notice this being dot notation. We're saying in the model, there's a variable called course, right? That's this variable here. It's defined up here. It's part of the model. What do we want from it? We want from the department object, which if you remember before, the department gets filled in. Because when we did that query, we said include department. So department gets filled in. And we want for that department the name of the department. So we get the department name. Now the next two things are lists. All right. So we're going to have to loop through those lists. We're going to loop through the instructor first, and we're going to loop through the students. So for the instructor, we specify for each item in our models, course objects, list of instructors, give me for that item the instructor's full name. So item is each element in that list of instructors for the selected course. And for that item, we want to pull the full name. So there we have the full name. Let me go and add another instructor to teach mathematics. Or calculus, rather. So now if we go to that course roster, mathematics, notice we see the two instructors. Why do we see the two instructors? Because we have a loop. We've retrieved the list of instructors associated with our selected course, and we're looping through and we're displaying the full name for each of those. And we don't have, they appear on the same line. Why? Because we don't have any HTML that tells it to not appear on the same line. We could format that certainly if we wanted to. Like I think we format the students as a list. Now we're going to loop through for that course variable in the model. We're going to loop through the enrollments list. And for that, we're going to pull, remember, item is going to be each element in the enrollments list. We want for that item in the enrollments list, we want the student's full name. Right. Now, this Linq language has two ways of doing things, two styles for the language, and you can mix and match. What we have here is called the method style. We're calling methods or functions. This is the one that I think is more straightforward. The other one I would suggest only using if you've done a lot of SQL programming before. And that I've done in roster 2, roster 1, which produces the same information, but goes about it writing the query a different way. Now, I know some students say, you know, why show us a couple different ways to do something? And I could appreciate that. It's, you know, you want to just learn one way to do it, and then you don't have to worry about a second way. Well, I think it's important to see a second way. First of all, one of the ways may resonate with you more. One of them may make more sense to you. Secondly, if you're working as part of a team, one of your teammates may be using the other style, or if you have to maintain a program that someone else wrote. So I don't want it to be a shock out of the blue if you see a different form of the query written. Let's see what we do here. Here I've taken a little bit different approach. I've actually created a separate course, department, instructor, and enrollments object. And I've said from C in course, context courses, where course ID equals ID, select the course information as well as the department information, instructor information, and enrollments. Then I'm populating from that query my variables. Course equals that item's course, department equals that course's department, instructor equals that course's list of instructors, and enrollments equals that course's list of enrollments. Then we pull for everything in that enrollment entity. For each item in the enrollment entity, we connect with the student. So enrollments will be connected and we'll have the student object filled in the enrollments object. The code to display it is very similar. I would actually redo this. I don't think you actually need these extra variables, but it made sense to do it that way when I was working on it and just using Linq for the first time, and you know, maybe it makes more sense to you doing it that way as well. Okay, let's look at one of your upcoming assignments, because I've gotten questions already from some students about this. So I thought it would be worthwhile discussing it. Check what assignment it is. Yeah, so one due tomorrow. But again, you know that I'm flexible as far as these assignments go. You're to create a menu that brings together category, meals, and notes. And if we're going to draw the relationship between them, category has a list of meals. Each meal has one note. All right. So let's think of how we want that to be. Let's look at this. When you're doing this and you're thinking of writing a query, again, ask yourself, is there one or is there multiple of that? And you should have an entity of category that contains a list of meals. You should have a meals entity that has one note entity. And you should have a note entity that has the description and other fields for that. So for this menu, and this is how I would suggest that you write this too, especially if you're struggling with that. What do we want to see? We want to see all categories. For each category, we want to see all the meals. And then for each meal, we want to see the notes. All right. So, category. Do we want a list of categories or do we want a single category? We want a list of them. All right. So there won't be any ID passed because we're not pulling up a single category. Our menu contains a list of categories. But for that category, we want to include the meals associated with that category. Right? And for each meal, then we want to include the notes. So I'm not going to write the code for this, but your model should look something like this. Or your query, rather, I'm sorry, should look something like this. Syntax. We want to then include meals. And again, I'm not paying attention to the syntax of it. Look at the example for the precise syntax. And then we want to include the notes. Why then include? Because notes are not associated with category. They're associated with meals, which is related to category. So your query for the menu should look something like this. You're going to produce a list of categories. You're going to populate the meals for that list, for each of the categories in that list, and you're going to populate the notes for each meal. Are there any questions over this? Great. I guess that's all I had today. If you have a course, if you have a class next Monday, it is Veterans Day. I don't know if students realize that, but the campus is closed for Veterans Day. So if you have a class Monday, check with your instructor, but your course is probably canceled for that day. All right. We'll see you next week or in lab.